Before I begin this tutorial, I want to show you a really neat video. It's called Lego Man in Space. Now what the person did is they put a little Lego piece and they attached it to a helium balloon. And you can see it goes up and up and up. And if you look, I know it's a little hard to see right now because it's fast, but you can see the curvature of space. They were able to send it up into the lower atmosphere. Now what eventually happened? The balloon popped and we can see he's back down to Earth. Now we're going to take a look at the exact same video, iPhone in space. But what's happening in this video is it's looking straight up at the balloon. So we can see the sky out there, and we can see the balloon spinning. I want you to take a look at the size of the balloon. As the balloon goes higher and higher, you're going to see the balloon gets higher or larger and larger in diameter, until eventually it gets so big it pops. Now this is very well predicted, so they could figure out more or less when it was going to fall. This is due to an idea known as Boyle's law. Now, all that Boyle's law simply states is that as external pressure starts to increase, gas molecules are forced closer together. As that happens, the volume of the gas decreases. So we've got, let's say, this scenario here. This is known as standard temperature and pressure, what we experience in our everyday lives. Now, if we start to go higher up into the atmosphere, we have decreased external pressure. This is due to being thinner air, less air molecules. As a result, what we see is this balloon starts to expand outwards at a very predictable rate. On the flip side, if we start to increase the pressure of our air, we can see that the balloon would start to get smaller. Now, where's an example of things as pressure increases, volume decreases? Well, we're going to take a look at a video here of me playing with a water bottle. Now, as we can see what happened there, I focused entirely on increasing the pressure inside. So I'm going to try that again. So what did I do there? I decreased the volume of the bottle. When I decreased the volume of the bottle, it started to increase the pressure on the inside. So rather than the cap coming off nicely, it shoots right off. Now we can mathematically talk about this, and what this says here is that volume is inversely proportional to pressure. What does that mean? Well, as volume starts to increase, pressure starts to decrease. Vice versa. If volume starts to decrease, pressure starts to increase. The volume of a given amount of gas at constant temperatures varies inversely with the applied pressure. Now, right over here, we've got this as a mathematical equation. So if we have two things, as pressure 1 and volume 1 increases, it will be equal to pressure 2 and volume 2 increasing. So we've got here a syringe, and I can sort of play with this. Now, as I start to increase the amount of pressure as I start to decrease the volume within the syringe, the pressure starts to increase. On the flip side, as I pull this out, pressure decreases. So I can either increase the pressure or create a vacuum within. So if I do this a whole bunch of times, you can see there's a data table that's being created on the right here. Now if we graph this data, we can see that we have sort of a curve shape going on here to indicate the inverse relationship. That's really hard for us to use math-wise, so we use the inverse. So 1p versus v. And as you can see, we're getting a straight, predictable line. So let's go through how we would use this in a mathematical equation. A weather balloon with a volume of 2 liters at a pressure of 96.3 kilopascals rises to an altitude of 1,000 meters, where the atmosphere is measured to be 60.8 kilopascals. Assuming there is no change in the temperature of the gas, what is the final volume of the weather balloon? First thing we're going to do, we're going to list down what we know and what we want to find out. We know that we've got an initial volume of 2.00 liters. And we know the initial pressure is equal to 96.3 kilopascals. Now we go to the higher altitude. At the higher altitude, we've got a decreased pressure. And much like my iPhone weather balloon that starts to increase outwards, start that pour over. Now that we start to get to the higher altitude, the pressure decreases because there's less air molecules. And much like my Lego man in space, the balloon's going to start to increase outwards. But we don't know how much. We want to figure that out. So P1V1 equals P2V2. Now we plug the values in. So now we need to rearrange, so we've just got V2 by itself. Which means V2 is equal to 2.00 times 96.3 divided by 60.8. So now I'll bring up my calculator and I will put it in. So 2 times 96.3 divided by 60.8. So our balloon is now 3.16 liters in size.